and make sure it's posted. Just make sure it is in fact recording. Great. All right, so I wanted to just share a little bit about our organizations for those of you who might not be very familiar with us. So the North Carolina Institute for Climate Studies, or NCICS, is primarily focused on climate data and science at the global, national, and regional scales, although its mission also includes bridging the gap between climate information and decision makers and stakeholders. And the State Climate Office, where I work, has deep knowledge of climate and weather at the state and local level here in North Carolina, and interacts directly with a range of stakeholders. So there's this natural synergy between our two organizations that can help us provide actionable information to state government, city planners, individual farmers, and others. And so we have a history of working together since about 2009 when NCICS began. And we've been working more closely together over the last year or so with the North Carolina Climate Science Report being a major focus. Other collaborative research projects are in the works, and these webinars are another outcome of that expanding partnership between our two centers. So NCICS and the State Climate Office worked really closely on the development of the North Carolina Climate Science Report, which we'll be talking about today. NCICS led the project and provided technical support throughout, and staff from both organizations served as authors on the advisory panel, did data analysis, and generated figures. So we really hope to continue to deepen our collaborations and provide more opportunities engaging with climate information like we are today. And so before jumping into the webinar today, I did want to just briefly tease the future ones that are coming up in the series. Later this month, on September 25th, we'll be doing a webinar on warming temperatures, extreme heat, nighttime warming, and impacts. And then in October, we'll be doing one on hurricanes and extreme precipitation. In early November, we'll be doing one on drought and wildfires. And then we are still lining up our speakers, but intending to do ones on sea level rise and talking about climate change in December. So we hope that you can all join us for those. Today's agenda, we have two talks scheduled. The first one will be by Dr. Kenneth Kunkel, and we'll take a brief break, just about 3 minutes, so we can all get up and stretch. And then we'll hear from Dr. Jess Whitehead. And then following this, we'll be doing a moderated Q&A. And it'll be moderated just because we have so many people on today, which is great. If you're not familiar with Zoom, the way we'd like you to ask questions or engage with us is using the chat. So just a little bit of Zoom orientation here. On the bottom of your Zoom window, you should see some controls to mute yourself. So please stay muted throughout. I'll be kind of checking too, and if you accidentally unmute yourself, I'll just mute you. We also asked, if you have, maybe internet quality isn't the best, just go ahead and stop your video. I'll be probably stopping my video throughout as well. And then finally, use the chat box to ask questions. I'm sorry, you can probably hear the trash pickup outside right now. Throughout, just click this chat box, a little window should appear. You can type your questions there throughout. We'll be checking, and then at the end when we get to that Q&A section, we'll be reading them off to the speakers. All right, so with that, I would like to introduce our first speaker for today. Dr. Kenneth Kunkel is a research professor of atmospheric sciences at North Carolina State University and lead scientist for assessments with the North Carolina Institute for Climate Studies. He holds a Bachelor of Science degree in physics from Southern Illinois University and Master of Science and PhD degrees in meteorology from the University of Wisconsin-Madison. He is the lead author of the recently released North Carolina Climate Science Report and has published over 165 scientific journals and book chapters. So with that, I'll let you take it over.
Okay, thank you, Rebecca. Can you see that fine? Okay, good. Okay, I'm going to jump in here, talk about this report that came out earlier this year. I'll provide a brief overview of how we put the report together and who was involved. And then I'll really delve into the report itself and talk about the report findings for North Carolina. I will also preface the North Carolina findings with what we know at a global level. And then in the report itself, we did put together 3 regional chapters to focus on sub-regions of the state. And so I'll show a few examples of that. So the motivation for the report was to support Governor Cooper's Executive Order 80, which was entitled North Carolina's Commitment to Address Climate Change and Transition to a Clean Economy. This climate science report represents an independent contribution to that executive order, peer-reviewed scientific assessment for North Carolina. And in the report, we address and show historical climate trends for North Carolina, and also show anticipated future climate change under increasing greenhouse gas concentrations. The report covers a variety of climate variables, temperature and precipitation, hurricanes, thunderstorms, and winter storms, sea level rise, and we also talk about air quality, wildfire, the urban heat island, and flooding in the state. The author team that we assembled included university and federal scientists from across the state. As Rebecca talked about, I'm located in a NOAA Cooperative Institute at the National Centers for Environmental Information. And the North Carolina State Climate Office provided both authorship and data analysis for the report. To ensure the scientific quality of the report, we also assembled an advisory panel. Some members of the advisory panel were also authors, but all are subject matter experts with national and international scientific reputations. And I'll show a map of those in just a second. Also here at the North Carolina Institute for Climate Studies, we have a unit called the Technical Support Unit that supports assessments in general, and in particular, the National Climate Assessment. So we've been heavily involved in both the 3rd and 4th National Climate Assessments, and are now working on the 5th one. So our contributions include authorship, project management, science editing and copywriting, and graphic design and production. So we treated this report much like we treat the national climate assessments. The Climate Science Advisory Panel, you can look at the names here. I just point out that represents a number of universities around the state, UNC Asheville here, App State, North Carolina A&T, East Carolina University, UNC Chapel Hill, Duke University, and then several authors and contributors from North Carolina State University. This shows the timeline for the report. This really was quite a rapid development of a report, given its size and the fact that we really wanted to make this a high quality report. We began just a little more than a year ago now in assembling an outline, assembling the team, assembling the Climate Science Advisory Panel. We wrote the report kind of in August, September, and October. We sent the report out for anonymous external review, and that was done during the winter. And then in late winter into March, we revised the report in response to review comments, and then issued it or released it on March 11th of this year. The report went through several review cycles by the Climate Science Advisory Panel. We also had a round of review by anonymous external climate experts. We actually list them in the report. They all agreed to be revealed after the fact. And then all the comments that we received were addressed in written responses recorded. The process used in developing this report is very similar to what we use for the National Climate Assessment, and it meets federal Information Quality Act standards. Okay, so now let me delve into the report and start out with the global foundation for the report. And there's some things we know with virtual certainty. One, CO2 concentrations are increasing rapidly. Primary cause for this is the burning of fossil fuels. CO2 is a greenhouse gas and it contributes to warming surface temperatures. The Earth is indeed warming, and increasing concentrations of CO2 and other greenhouse gases are most likely causing much, if not all, of the warming we observe on the Earth. Just to add another element of that, we have examined, we, in the broad sense of climate scientists, have done lots of research examining other potential causes of this warming, and the increase in greenhouse gas concentrations is the only plausible cause that is consistent with the observed data and the physics that governs the climate system. In the report, we not only made statements about what could happen in the future, we also assess the likelihood of that. And we use this particular table of terms, and I'd like you just to kind of spend a second here looking at this. The term virtually certain means that we have at least a 99% probability of the outcome. Very likely means at least 90. Likely means kind of 2/3 or greater. And then we use some confidence statements where if we say low confidence, it means that there is inconclusive evidence or disagreement or a lack of expert opinions about it. And medium confidence is just as it says, it's a little bit higher. We have more evidence or a greater level of agreement on the outcome. Okay, so continuing on the global context, if we look at global temperature, it's increased by about 1.8 degrees Fahrenheit since 1895. And as I said before, climate scientists are in general agreement that this increase is largely due to human activities, increasing greenhouse gas concentrations. We have very high confidence in that statement. And it's virtually certain that global warming will continue if greenhouse gas concentrations continue to increase. We do a lot of work with climate models. I'm not going to be talking about climate models today, other than to point out that's part of what we use for assessing what could happen in the future. And if we look at projected global temperature increases for the end of this century compared to around the turn of the century, we find increases in temperature of 4 to 8 degrees under what we call a higher scenario, one in which greenhouse gas concentrations approach 1,000 parts per million. They're now about 400 plus parts per million. And about 1 degree to 4 degrees Fahrenheit under a lower scenario of greenhouse gas concentrations where they level off at between 500 and 600 parts per million. And we use these two scenarios throughout the report to kind of show, kind of a high and a low. These aren't predictions of what could happen, but if that scenario was realized, then these are likely outcomes. What about global sea level? What's been rising? It's increased by about 7 to 8 inches since turn of the 20th century. Almost half of this increase has been since 1993. It's virtually certain that global sea level will continue to rise due to two factors. One, expansion of ocean water from warming. When water warms, it expands. And melting of ice on land, including Greenland and the Antarctic ice sheet. So the two things that can happen is simply the mass of water expands, or we add to the mass of water. And both of those are happening right now and expected to continue if warming continues. Okay, so the high end or the high level finding for North Carolina is that large changes in North Carolina's climate outside of the envelope of what we experienced during the state's history are very likely by the end of the century under both the lower and higher scenarios. And so now I'm going to start moving through individual kind of climate variables, climate elements here, and talk about them. First, temperature. What's been happening with temperature? Well, we've been warming in the state. If you look at the graph on the right, you see fluctuations in, this is annual average temperature for North Carolina. It was pretty warm in the 20s, 30s into the 40s. It was cooler in the 60s, 70s. Since that time, it's been warming. And in fact, if we look at 10-year periods throughout this record, the very latest 10-year period that we analyzed, we stopped our analysis essentially at 2018. It's the warmest 10-year period on record in North Carolina, and about a half degree warmer than the warmest previous decade, which was the 1930s. Well, 2019 happened while we were writing the report, and we did add this to the report. That is the warmest year on record for North Carolina, and it was also the second warmest globally. What about projections of temperature? We assess that it's very likely that North Carolina temperatures will increase substantially in all seasons. It's also very likely that we will see an increase in the number of very warm nights. These are nights when the temperature doesn't fall below 75. So, you know, these hot, warm, sticky nights that we tend to get around here. Very likely that those will also increase. It's also likely that there will be an increase in the number of hot days and a decrease in the number of cold days. Hot days, in this case, being 95-degree days when the temperature gets to or exceeds 95. Now, you'll notice here that there's a lower level of confidence or likelihood on the increase in the number of warm nights than the number of hot days. Now, that's because of the historical experience that we've had in North Carolina. And it's true for much of the eastern part of the US that we have seen little or no increase historically in the number of hot days, but we've seen an increase in the number of very warm nights. So we've combined really three factors here. We've combined what's been happening historically, what do the models project, and then from basic physics principles, what would we expect? And so that has informed this level of likelihood that we put on these statements. So we have higher likelihood that number of warm nights will increase because they have been increasing and the physics all point in that direction, but slightly lower likelihood on hot days and cold days. Okay, now turning to precipitation. There is, on the right-hand graph, you can see the long-term trend going back to 1895 in annual precipitation average across the state. And there's no long-term trend in this graphic. However, 2018 was the wettest on record. This included Florence. Florence was not the only reason that it was the wettest on record, but it certainly made a major contribution to the total for that year. 2020 is also turning out to be a wet year so far for the state. Obviously, the book's not closed on that yet, so we won't know what it turns out at the end of the year. But right now, it's well above normal for the year. We have seen an upward trend in the number of heavy rainfall events in the state. In the report, we define these as number of days when a station gets more than 3 inches of rain. So how many stations in a year got 3 inches of rain on a single day, for example. The last period that we looked at in our reports, that had the highest number of such events. What about the future? What do we expect? What is likely that annual total precipitation for North Carolina will increase? And why do we think that? Why do the models project that? Well, there's a general, if one looks globally, there's a general pattern of change in the future where the kind of middle to high latitudes get wetter, primarily because there's more water vapor in the atmosphere. I'm going to come back to that several times during this talk, including the very next item. And the subtropics tend to get drier. North Carolina is actually on the southern end or southern border of the area that the models project to experience increases in total precipitation. So we've gone along with these model projections and kind of the overall global patterns that we see and assess that it's likely that that will increase. However, it is virtually certain that atmospheric water vapor content over North Carolina will rise. And that's due to some very simple physics. It's due to the warming of the ocean primarily, and the fact that the amount of water vapor that the atmosphere can hold increases with temperature. So as the oceans warm, the air above the oceans becomes moister on average. And North Carolina being so close to the coast, adjacent to the oceans, we would expect to experience increases in water vapor in the future. Now, as a result, if we don't look at just total precipitation, we look at only the heavy events. Our research has shown very clearly that the amount of precipitation, the amount of rain we get in the heaviest events is primarily determined by water vapor, how much water vapor is in the atmosphere. And it's virtually certain that that will rise. And so we assess it as at least very likely that extreme precipitation and intensity in North Carolina will increase. So this is one of the features of the climate that we have the kind of the highest confidence that there will be change in the direction that it will change in. Sea level. Sea level is rising about twice as fast along the northeastern coast of North Carolina as along the southeastern coast. It's been rising at about 1.8 inches per decade at Duck and about 0.9 inches per decade at Wilmington. And these differences, kind of the overall increase, is due to the fact that global sea level is rising, but there's also geologic factors going on in the northeastern coast of North Carolina. There's geologic subsidence going on. So that's adding to the relative sea level rise because the ground is essentially sinking along with global sea level rise rising. Looking ahead to the future, in this case, we can say it's virtually certain that sea level will continue to rise along the North Carolina coast. When we talk about global sea level, for the most part, it goes up everywhere. Now, there are some other factors that come into play that modulate that at local places, but we're kind of going along with the rest of the globe here in North Carolina. We will almost certainly see sea level continue to rise. If we look at the extreme high water levels along the coast, in the report we talk about essentially what you might call a 100-year storm or a 100-year flood along the coast. That's something that on average has a 1% chance of occurring each year. Because overall sea level will rise, that may increase to as high as 30 to 100% by the end of the century under the higher emission scenario, simply because if a storm occurs, whether that's a hurricane or a nor'easter, the sea level rise it occurs will be occurring on a higher baseline. Also, because overall sea level rise is projected to increase, high level or high tide flooding is also projected to increase and in fact become nearly a daily occurrence by the end of the century. This actually shows an assessment by NOAA scientists about the overall change in mean sea level at Duck. Under this particular projection, it's likely that sea level will rise, the mean sea level will rise by 2 to 4 feet by the end of the century at Duck. Well, if you look at high tide flooding, these are the two kind of lower and high scenarios, but even under the lower scenario, which is the low end of this red band, it becomes almost a daily occurrence by the end of the century. Now I'm going to switch to hurricanes, obviously another important topic for North Carolina. We did an assessment for the report of the total number of tropical events for North Carolina. These are tropical storms or hurricanes that either cross the state or have crossed the state or come close enough to the state to have some sizable impacts. And if you look at the long-term trend, we have record of this going back to the middle of the 19th century, so a very long record here. There is no long-term trend in this particular variable. That becomes pretty important in just a second here when I talk about what we expect for the future. It's been kind of above normal for the last couple decades, and in fact, these are 5-year intervals here, and the highest number of events over a 5-year period occurred in 2000 to 2004. Okay, talking more about hurricanes, hurricanes are primarily driven by high amounts of water vapor. In fact, they require a certain level of water vapor to even have a chance of forming. So they always develop and intensify over warm ocean waters because that's where the water vapor is the highest. But other factors are necessary for a hurricane to form, particularly low wind shear. So water vapor is not the only component that affects hurricane formation and development. So what can we say about the future? Well, we can say, because of the primary physics of a hurricane, that it's driven by water vapor and thus by how warm the oceans are. And the highest intensity of the hurricanes is sort of driven by that if all other factors are favorable, that the intensity of the strongest hurricanes is likely to increase. That's a statement that's made on a global scale. I think that's kind of the, if you go down to a regional scale, to any regional scale, like North Carolina, the confidence becomes less because there could be other things that happened over time that could impact it at the local level that we're not sure of yet. But I think we can say that global warming could result in stronger hurricanes impacting North Carolina. And we have medium confidence for that statement. High confidence for global changes, medium confidence for North Carolina. What else can we say about hurricanes? Well, it's very likely that heavy precipitation accompanying hurricanes will increase. And that goes back to this water vapor relationship with extreme precipitation. Extreme precipitation amounts are directly driven by water vapor content on average. And when hurricanes form, they will have more water vapor available to them, and therefore the potential for heavy rain will increase. And that could increase freshwater flood potential in the state. However, we have low confidence concerning future changes in the number of landfalling hurricanes in North Carolina. So if you look at the historical trend, there has not been a trend in that. Also, hurricane experts and looking at climate model simulations, there is no clear signal about what the direction for the number of hurricanes. The strongest evidence is that the strongest hurricanes will increase and that there will be more precipitation from them. Okay, what about storms? It's likely that the frequency of severe thunderstorms will increase. That statement is primarily driven by our understanding of what causes severe thunderstorms and the fact that water vapor will be higher in the future. It's likely that total snowfall and the number of heavy storms will decrease simply due to increasing winter temperatures. Moving some storms that now produce snow will produce rain in the future because they'll be warmer. And there's low confidence concerning future changes in the number of winter coastal storms, nor'easters, and also ice storms. What about floods? We already talked about coastal flooding because of hurricanes and nor'easters occurring when baseline sea level is higher. So we're virtually certain that there will be increases in storm surge flooding. And it's likely that increases in extreme precipitation will lead to increases in inland flooding. What about drought? Drought is a complicated meteorological phenomenon. We have assessed that it's likely that severe droughts will be more intense in the future. Just like to take a minute to talk about that. We don't have any clear evidence that the kind of number of dry spells, periods of deficient precipitation will change in the future. You know, kind of the large scale weather patterns, circulation patterns that cause those. However, it is very likely that those dry periods will be warmer. And if they're warmer, the rate at which soil moisture is depleted will be more rapid. Therefore, we'll reach what I would say is impactful low soil moisture levels faster in a dry episode than what has been the historical norm. That is the basis for the statement here that's likely that severe droughts will be more intense in the future. When we have a very long, dry spell, temperatures will be warmer, soil moisture will be depleted more rapidly, and for those things that are affected by that, in particular agriculture, are likely to see impacts on crop yields happen earlier in such an episode. That also means that if we look at another aspect related to drought, wildfires, that the frequency of climate conditions conducive to wildfires will likely increase in the future. And that's really saying that low soil moisture levels are likely to increase in frequency in the future. Okay, some other features. The urban heat island, if you're not familiar with that, this is a phenomenon in which urban areas have a limited amount of vegetated surfaces, and therefore one of the features of kind of summer climate in more rural areas is in which vegetation, trees, crops, whatever it is, tend to reduce the amount of heating because the vegetation is evaporating water and modulating heat increases. That's not occurring to the same extent in cities. So cities are generally warmer because they have asphalt, concrete, things that do not evaporate. As we look ahead into the future, all the projections for North Carolina indicate a continuation of the growth in population, and that's primarily in the urban areas. And so the combination of overall warming and larger urban areas, we assess it likely that there will be larger heat island effects in our urban areas. And ozone or air quality conditions. We have low confidence concerning any future changes in near surface ozone formation. And that's primarily because two of the major influences on ozone formation might have counteracting influences. Ozone formation is favored by higher temperatures and lower humidity levels or lower water vapor levels. However, while we expect to get increases in temperature, we also expect to get increases in water vapor concentrations. So those two might cancel each other. Now, these changes in climate, it's very likely that the design standards that we use for building infrastructure, or constructing buildings and other infrastructure, will change by the middle of the century. Currently, for instance, if a building is being constructed, there will be design standards that are used to determine, for example, insulation and the sizing of heating and air conditioning systems. Those are going to be out of date if we continue to warm. And particularly, we would expect that increases in design values for precipitation and dry bulb and wet bulb temperatures would be more suited for buildings and other infrastructure that have multi-decadal lifetimes and will experience changes in climate during their lifetime. Okay, as I indicated, we do have regional chapters in the report. We have chapters for the Western Mountains, Piedmont, and the Coastal Plain. And we have graphics, similar set of graphics for each of those regions. Here I show an example for the Western Mountains where I show the number of wet days, what's happened or rather hot days, what's happened historically. In the mountains, we use 90 rather than 95 for a threshold for that. And the number of warm nights, nights that don't fall below 70, once again, using a lower threshold in the mountains. And you can see here something I said before, we don't see a trend in hot days in the mountains, but we do see an upward trend in warm nights. Here in the Piedmont, here's a couple of examples. On the left are the projections for annual average temperature as we go forward into the future. And you see the large temperature increases that are projected to occur under both the higher and lower scenarios. On the right, you see the number of 3-inch days at stations in the Piedmont, and you'll notice the high values at the end of that time series. Here in the coastal plain, I'm showing annual cooling degree days. Cooling degree days is a metric that can be tied to the amount of energy used for air conditioning in the summertime. And you notice that in the last couple of decades, that's been increasing because of warmer summer temperatures. And on the right, again, we have projected values for the hottest annual temperature, maximum temperature, and the lowest minimum temperature, and both of those are rising as we go forward into the future. So final thoughts for North Carolina. The high-level messages, I think, are the most important things I hope people will remember is that, first of all, we expect large future changes in climate if our current reliance on fossil fuels for energy continues. Some of the major highlighted changes we might expect are temperatures outside of the historical envelope, disruptive sea level rise, increases in intensity and frequency of extreme rainfall, more intense hurricanes, and higher absolute humidity levels. I haven't said much about this last item except as it relates to hurricanes and extreme rainfall, but it has obvious implications for summertime human stress under heat, where the temperatures will increase, but maybe more importantly, humidity levels will increase. And so the kind of apparent temperature that one feels will be even higher than will be indicated by the temperature increase alone. We had a large team working on this report. I've talked about some of these elements. I would note that North Carolina's Department of Environmental Quality was our contact on the development of this report, and they helped us a great deal with coordination and also interfacing with cabinet level departments. So we knew what kinds of things they were interested in, and so we could kind of target the report to what would be of most relevance and interest to those departments. Just another thing here, you notice there's the list of reviewers on the lower right-hand side. For those who are in the climate field, those names would be very recognizable and include Ryan Boyles, who is Kathy Dello's predecessor as North Carolina state climatologist. And I think we're going to hold questions until the end.
Yes, thank you so much. That was very enlightening, and I really appreciated that you were able to break things down into very small digestible pieces, and I thought that was fantastic. Yeah, so we will hold questions, actually doing a Q&A until the very end, but if anyone has any questions, please feel free to go ahead and type them into the chat. We are monitoring that and documenting them so that we can ask them, so please feel free to go ahead and type them. We're going to take just a quick break for about 3 minutes. So if we want to reconvene at 1:45, we'll get started with our next talk. Jess, if you want to go ahead and share your screen, just go right ahead. And if not, we can just wait until 1:45.
Yep, I'm going to go ahead and switch it over.
Great. Great, I do see it. So that's good. Right, well, it's 1:45, so we'll go ahead and come back, and I'll go ahead and introduce our next speaker, who I'm also very excited to have with us today. So Dr. Jess Whitehead is the Chief Resilience Officer with the North Carolina Office of Recovery and Resiliency and the North Carolina Department of Public Safety. As Chief Resilience Officer, excuse me, she leads an innovative team that is building out the state's initiative to help storm-impacted communities rebuild smarter and stronger in the face of future natural disasters and long-term climate change. Dr. Whitehead earned her Doctor of Philosophy in Geography and Master of Science degree in Meteorology from the Pennsylvania State University. She also earned a Bachelor of Science degree in Physics with a concentration in Meteorology from the College of Charleston. And we're really excited to have her here today. So Jess, if you want to go ahead and take it away.
Yeah, thank you so much, Rebecca, and thank you all for having me. I'm going to launch right into it because I want to be absolutely sure that we have plenty of time for discussion, because there were a lot of great questions for Dr. Kunkel that were coming through on the chat during the break. So I want to back things up a little bit further than Dr. Kunkel did and talk a little bit about what was Executive Order 80, where did it come from? EO 80, and I'll disclose full disclosure, I was not with the state of North Carolina at the time. I was actually with NC State University and the North Carolina Sea Grant program. So I've got my red back on today. The Executive Order 80 was in progress and actually scheduled to be released when Hurricane Florence hit in fall of 2018. So the release of EO 80 was delayed until October. And I think really Hurricane Florence, with the second, I hate using 500-year storms because that implies that they only come once every 500 years. The reality is that any 1 year, it's a storm that has a 0.2% chance of happening. And the reality is that you could get them in any 1 year, and in back-to-back years, or in the cases of Florence and Michael, Florence and Matthew, two of them within a 23-month period. And the reality is that even though these events are statistically looking at probability exceptionally rare, the devastating impact to the people who live, work, and play in the state of North Carolina really can't be understated. We'll be rebuilding from these two storms for years to come. And across the country, we see with any one of these major disasters, rebuilding from any of these disasters is really an ultra marathon and not a sprint. There are so many different needs, different agencies, unmet needs that are not necessarily covered by any federal programs, and it becomes a very complicated environment. And what this really did was, I think, renew the state's resolve under Governor Cooper's leadership to begin addressing extreme events and climate change much more proactively than we had in the past. And so EO 80 really covered a number of things. It's an executive order, so it applies to cabinet agencies. But the key here, and the key part that I want to talk about, in addition to the Clean Energy Plan that was produced under EO 80, the Zero Emission Vehicle Plan, the Greenhouse Gas Inventory, is Section 9. And this is the development of a risk assessment and resilience plan. And if you'll think to the timeline of October 2018, so just shy of 2 years ago, we're talking about not just producing a statewide risk assessment and resilience plan, but 4 other major products dealing also on the clean energy side. And none of what has happened with Executive Order 80, Section 9, and any of the other products could have happened without the leadership of Sushma Mazemore in DEQ. And so even though I'm talking about this section of it today because the idea of a chief resilience officer came along in the middle of this process, it really is under Sushma's just sheer force of will that all of this came together. So I want to make sure that I've got her name out there with full credit to the amazing job that she did. Now, in the middle of this, what is NCORE and where did we come from? In very late October of 2018, the governor's office, working with the General Assembly, was also putting together funds for recovery for Hurricane Florence. And the Office of Recovery and Resiliency was born, recognizing that you really need one agency who is beginning to coordinate and run point on collaboration for not just one, but two disasters on the scale of Matthew and Florence. The resilience team was fully staffed by June of 2019. So it took quite a bit to figure out how do you establish a statewide resilience office. The majority of the rest of NCORE, and we're a sister agency to North Carolina Emergency Management. Director Mike Sprayberry is the director of both. NCORE is under our COO, Laura Hogshead, is really to administer the HUD funds. So the funds of last resort, the funds designated by the Housing and Urban Development Administration to really provide that last resort of disaster aid to low and moderate income communities. So North Carolina is receiving several different tranches of this CDBG disaster recovery funding from Matthew, a mitigation fund specifically for Matthew, and then CDBG DR for Florence. A shout out to the rest of NCORE, who really has done an amazing job since us coming into existence. We have been a HUD on-pace spender for our HUD grants since last September. Our mitigation action plan was the first one approved in the nation. And then even though we could not specifically launch our action plans with Florence until the publication of the rules for that program in the Federal Register, which took nearly 500 days since the landfall of Florence for those rules to be published in January. North Carolina was the first one with its action plan approved by HUD in the nation from the 2018 storms. And our homeowner recovery program is already open, taking applicants. And we even, getting a brief this morning from our NCORE Chief of Staff, we already have some applicants for the Florence program who are in step 4 of our 8-step program for recovery. So it's an incredible program. But where does my team fit in on resilience? We do a number of things, and I'll talk about those in a minute, but stepping back to the statewide risk assessment and resilience report. This is something where it's a monumental task, short amount of time, very, very little budget. So Sushma Mathmore was just really incredible in terms of getting partnerships on board, getting the assistance of the university system, Dr. Kunkel, everyone at NCICS, everyone at the State Climate Office, and the number of our other climate partners. We appreciate your support so, so much. But then also coordinating 10 different cabinet agencies. Plus, even though they were not required by the executive order, the Department of Agriculture and Consumer Services has been doing a lot of work on climate risk and resilience, and so opted into participating on this process. So moving through by December 19, really having underway a climate science assessment that would provide a resource to the rest of us who are staff of all of these different cabinet agencies to begin thinking through our exposure to climate-related hazards, how that affects the assets that the state manages, and also the services that we provide to local governments. And then assessing the vulnerabilities and risk and beginning to develop some action. Our timeline was initially to be released by March of 2020. Then we had COVID happen, and all of the entire report had to be signed off on by the secretary of each agency. So as you can imagine, beginning in February, my own agency, Department of Public Safety, Department of Health and Human Services, some of the other agencies became fully engaged in COVID response. So we released the report on June 2nd of 2020. What went into this report? In addition to the independent climate science report, we made sure that we had local government input. And this was a process that was actually begun back when I was with Sea Grant. I was working with the Coastal Work Group, but we also had a number of other Piedmont and mountain work groups to make sure that we had input from the local governments about not just the information that they needed to know, but how they were going to be able to use it and what resources they needed from the state agencies. So we had government officials, local planners, community organizations, emergency management, businesses and other supporting agencies, and really cutting across the public health sectors, ag sectors, environment and natural resources sectors, planning and transportation. This was really a great effort, and a lot of participation went into making sure that we knew what people needed out of this report. Now, at this point, I've used the word resilience a lot of times, and you're probably wondering what it is. Our team really takes a view of resilience, and as our team came into this midstream in terms of the production process of the report last summer, we really bring a concept of resilience to the state that focuses on a triple bottom line approach. It's not just the environmental value of resilience, it's also the economic value of resilience and the social aspects of resilience that really go behind what matters to our communities. And it's not just an idea of being able to build things back the way that they were, because I don't think, looking at the challenges that our rural areas face, looking at what was already an affordable housing crisis before Hurricane Matthew even hit, that any of us would say that we really wanted to turn back the clock to August of 2016 in terms of what our state looked like. We want to build back stronger, smarter, and safer. And really, sometimes that requires not just building back, but adapting to and bouncing forward. And thinking about a number of these challenges, whether we're talking about disasters, whether we're talking about climate change. Now, if we're talking about pandemics, to really bring that perspective of, not just the environmental value, but also growth that our communities need and our quality of life, because there's a reason that we all live, work, and love the state of North Carolina. So in this, the climate science report, and Dr. Kunkel's already given an excellent overview. So I really just sort of wanted to highlight again that this is a key part of the risk assessment and resilience plan. And please do access it, because it is full of not just a whole bunch of graphs, but really information that will help you make your own decisions, help the people who you work with, whether it's farmers, whether it's rural communities, make better decisions. So take a look at that good science base. And what's in the report itself? We do go over the process of the development, but then I think the biggest pieces that are really relevant to you and your work with cooperative extension are, there's an entire chapter on climate and environmental justice and the ways that climate change really impacts some of our most low income, moderate income communities, and then Black, Indigenous, and other communities of color, and really making sure that they have place as part of the process, that voices are heard, that voices are a key part of this, that we are including everyone as we move forward on climate change in the state. We also have the vulnerability, risk, and options for the climate-related hazards. As you can imagine, we really only in some cases were able to scratch the surface given the timeline. It's much easier to think about the impacts that climate change will have to a building than it is to really think through and say, what should my policy be to support economic development in a rural area under climate change? Some of these things are just going to be continuing conversations that the agencies and local governments and everyone who lives in North Carolina needs to continue to have to understand what our best strategies are. But it covers everything from agriculture and forestry to commerce and business to housing, building, and support services, health and human services, public safety. Believe it or not, public safety is not just impacts to emergency management and disaster recovery. It includes things like our correctional institutions and employee health and safety, and human health and safety too, transportation and energy. There's also a nature-based solutions chapter, and that recognizes the pre-existing natural and working lands group that was really gelling together as a community of practice even before EO80 came along. And so that was one of the groups where they were really able to, they had the support, they had those previously existing connections to really be able to move that forward into a full cross-sector kind of chapter. And then our path forward. So what is the path forward and where do we go from here? And this is where NCORE begins to come in, because now the state does have a chief resilience officer. So the transition here is, from DEQ, which remains engaged and has a whole lot of leadership in some of the other elements related to energy and that part of energy and environmental preservation, and even the greenhouse gas inventory roles that live over in DEQ. But as we're looking at the path forward and what matters to people on the ground, there are so many places where disasters and thinking about disasters become the closest place where you can really have these cross-sector conversations, because when you're thinking about disaster recovery, it's the environmental piece, it's the economic piece, it's the social fabric piece. And so building on that and placing it in Department of Public Safety becomes the logical place to pick up that transition. So we're looking at 4 different elements, as opposed to we're going to sit on this and produce another plan 4 years later. We really wanted to create a path that would lead to implementable actions on the ground. And so this involves continuing to support state agencies as they build out their strategies with an annual reporting requirement, beginning to look at the context of how do we make decisions based on what we know from the science on responding to extreme events, and making sure that what we look at in that process is incorporated into the 2023 update of our statewide enhanced hazard mitigation plan. And then the last piece is really understanding that there are some cross-cutting, wicked challenges that are going to need a whole lot of public participation, a whole lot of deliberation, a whole lot of really creative and purposeful thought. So things like potentially dealing with sea level rise or dealing with our long-term water resources. We want to make sure that those are not things that just get tacked onto a hazard mitigation plan, that we're providing space to have what can be very challenging discussions on what the different solutions are that the state should pursue. I'm going to skip this talking a whole lot about this. It's sort of the inside baseball behind what went into the chapter, but just providing you that, a little bit of evidence as to why we're looking at this type of approach, this real implementation driven as opposed to a report driven strategy. And it's really making sure that we're providing a space and a pathway to making sure that we're setting goals, making sure that we're implementing and monitoring progress, making sure that we're adequately incorporating uncertainty. Because as you heard, there are a lot of areas where we may or may not have high confidence, or we have lower confidence but may still need to make decisions. So we wanted to really be sure that we're creating the space to follow what is the best practice coming out of the research on what is resilience and what is an effective way of building it. So we provide guiding principles as a part of this path forward, and it includes, in some cases, we need to act quickly and decisively, where we know there are very clear-cut things that we need to do, things that agencies are already doing, like finding different ways to make disaster recovery that right now is across multiple different agencies. How can we coordinate better and better leverage each other's effort? That's a win-win situation no matter what. But then also making sure that we're providing spaces for thoughtful and collaborative deliberation about some of these very, very challenging aspects of climate change. We know that some of our most vulnerable communities, especially Black, Indigenous, Latinx communities, tend to live in places that are very flood prone. And so how do we develop processes where we're really working with those communities to find solutions that they want, not that are imposed from the outside? That takes time and that takes effort. We want to make sure that we're investing in safe, affordable, and connected communities and strengthening economies. Looking for sustainable funding, that's a challenge nationally. So whether it's looking for new sources or making sure that we're using existing sources like disaster recovery funding as efficiently as we can to also improve resilience, we've got to find those opportunities. And really becoming an example of best practices. Our cross-sector strategies are to consider resilience criteria whenever we're making investments. So don't just think about tomorrow, think about what's the entire lifetime of this investment that I'm making, whether it's a rural water infrastructure project or a broadband project or a transportation project, and thinking about different ways to update design standards and values. I know, there may be a tendency to know that we need to have these updated, but we have infrastructure that we're putting in the ground now. We want that to last. So we really need to take some effort to look at what is the funding streams for those, what are the regulations involving those, And are there ways to make those more flexible so that we're not necessarily just building to today's climate, but if we're building something that's supposed to last for 50 years, and it's not something that can be easily retrofitted, especially by a rural government, then what are our abilities to make those designs, to increase the way that we're designing that infrastructure? So we're designing the infrastructure of the future. Increasing resilience capacity, again, funding resources, funding comes up a lot, and then communication. So priority initiatives for the state are maintaining and coordinating statewide resilience. Our state agency, interagency resilience team will be having its first meeting this month. And then I wanted to really talk about and hone in on another thing that we call for is the establishment of a North Carolina Resilient Communities Program, because there are two agencies in particular, the Division of Coastal Management and my own agency, who have gone out and sought external funding from the National Fish and Wildlife Foundation and from the Economic Development Administration to be able to begin addressing what we heard strongly from local governments, that local governments need technical capacity, they need funding, they need time to be able to integrate resilience into their operations and to think strategically about this and to really make things happen on the ground. So I'm going to specifically talk about, because we're limited in time, just y'all are getting a preview. You're my first audience that I'm really openly talking about this with. Our funding from the Economic Development Administration. This is thanks to an investment from the FY19 disaster supplemental funding for Hurricanes Florence and Michael. And this is, it's very closely modeled with, if any of you attended the Division of Coastal Management Resilient Coastal Communities Program. And in fact, a lot of us work together making sure that we had enough, they're clearly separate grants, but there are complementary approaches so that we're as efficient as we possibly can in piloting some of these approaches in the state of North Carolina. What the EDA grant will do, and why I wanted to make sure to talk about it with audience from Cooperative Extension, is that the focus will be on rural communities and regional approaches, knowing that there are some counties that have a single contracted county manager that's shared between 4 counties. So capacity is limited. We know that we need to work differently and figure out ways to help you partner up the ways that you need to be able to do this kind of different strategic planning for resilience. Why looking strategically at resilience? The reality is that as we get from plans to action, places have a lot of plans. Those plans don't necessarily talk to each other. So having some kind of framework that will really look at the dimensions of resilience and how to look at preparedness and connectedness and adaptability across these number of plans is really key to helping communities work forward consistently, whether they're in Murphy or Manio. There's going to be a focus on really how we help communities think about resilience every day, whether that's disaster resilience or climate resilience, but thinking about these future risks, how to avoid suffering in these risky areas, and using connections and collaboration to make sure that you're investing and upgrading wisely and doing this plan integration. These are all really key underlying approaches to the way that we structured this grant and the products we expect to come out of it. So we've just received the funding at the end of July. So we've had about a month. It's the first time the Department of Public Safety is receiving funding from the EDA, so we're having to do some setup. Next month, October, we'll be rolling out some workshops I'll talk about in a second. But the first deliverable that's going to move in parallel with some of these workshops is the development of a statewide resiliency framework. And this will really involve building out, based on the climate risk assessment and resilience plan and other work that's been done in the state, this idea of a guidebook that communicates these resilience goals, principles, and strategies for the state. This is modeled after the approach that the state of Colorado uses to support their communities on building resilience and incorporating climate change in what they're doing. The second deliverable is a partnership with the North Carolina Rural Center and the Councils of Government. And so this will help us to integrate resilience curriculum as a part of the North Carolina Rural Center's Homegrown Leaders East initiative. And then future iterations of the Homegrown Leaders program will also have this curriculum at their disposal. We're looking at different ways to pivot through COVID, knowing that it's difficult to have very large groups of meetings and having the space for that. So next month, look for announcements soon. We'll be running a Rural Resilience webinar series on Wednesdays in October. And then the final piece of this, and this is where there's a similarity to the municipal level approach that Division of Coastal Management is taking with their funding, is having some technical capacity funding that NCORE will hold and be able to direct toward the needs of resilient rural partnerships that are based on the boundaries or the sub-boundaries of the councils of government or other. If somebody inside a COG wants to work in a watershed, that's great, we'll help you do that. We can't sub-grant with EDA, but NCORE can hold the funds, contract on your behalf, and make sure that those needs are met. And I think in the long run that this will make it a little bit easier because then we don't have that funding administration on the, there's care and feeding, there's staff time that goes into funding and contracting and procurement and all of those things. NCORE can do those and get the work done, meeting the need of that rural partnership without them having to handle the administration. So in the long run, I think we'll be able to work a little bit more efficiently and get some things more done in this partnership with NCORE. And it'll provide technical expertise, coaching for rural resilience partnerships, and some real assistance in beginning to prioritize resilience projects, whether those are hard infrastructure, green infrastructure, economic development. We want to take a real comprehensive look across the social, environmental, and economic fabrics of these regions to do some good for rural communities. So with that, I'm going to toss up my my contact information. There's a lot of other things going on that I could have talked about, but I think for this one, this is the most exciting upcoming activity for those of you who are involved in cooperative extension. And I'm really looking forward to interacting with some of you, I'm sure, through the course of this grant.
Thank you so much. That was so informative. And I guess speaking for myself, it makes me very excited to see everything that's going on in the state. I'm very proud to live here in North Carolina. So we will switch to a Q&A. And so if anyone has any questions, please feel free to go ahead and type them into the chat. And I will, nice little. Everyone can see my just reminder on how to do that. If you haven't. All right, great. Oops. So we had a couple of questions that came across earlier, and I saw that Dr. Kunkel, you were answering them. I wanted to just kind of share some here verbally for the group. So one of the questions that came across initially was about the temperatures and the precipitation data that had been used in some of the calculations or the maps or the graphics. Where does that data come from that is used in those?
Yeah, just to expand on that. So most of those data that we use in this come from something called the Cooperative Observer Network, which is run by the National Weather Service. This was established in 1890 across the US. At that time, it was in the Department of Agriculture, then eventually moved to the Weather Service. But it consists of observers who are largely volunteers, either institutional or individual volunteers who are trained by the National Weather Service. They get equipment from the National Weather Service, so it's kind of standardized equipment. And the idea is that they hopefully will report for many years, and we have stations in that network that have reported for more than 100 years. So that is probably the best source to determine truly what's happening in the climate. The stations that we used for this analysis are, we limited it to only long-term stations. So we're not talking about stations in 1990 being a lot different than in 1940. There are some changes that happened, but we're largely using the same set of stations. So what we're trying to do with our analysis is to kind of isolate changes in the network from changes in the climate by choosing only the kind of the longest stations. So I think, I don't know if that's enough information, but that's kind of a verbal description of what I tried to write.
Thank you. Yes, no, I think that was very, very great. This next question I think is for Jess maybe is, do we have resources for folks that work outside? The implication with higher temperature and higher humidity is increased stress for outside workers. So
that's a great question. And I know that that's something that DHHS and the CDC funded BRACE program, which I forget exactly what the acronym stands for, but a woman over there named Lauren Thie has really been working with the University of North Carolina and the Carolinas Integrated Sciences and Assessment and several other partners on a tool called Convergence that identifies the problem, and where we see, I mean, you can even overlay and see during these events, it's rural communities where we have the largest number of emergency department admissions during or lagged behind some of these heat events. But I think in terms of beginning to synthesize those resources, we're really on the ground floor. I do know that CISA is starting to try to pull together a extreme heat working group that could begin to start helping us address some of these things. But that issue of, you know, extreme heat comes up across the, you know, DHHS, labor, agriculture, state workers who work outside, you know, our law enforcement or our National Guard who all work outside. So it's a big challenge. And I think we're on the ground floor of starting to develop how do we want to address these issues.
Great, thank you. And I'm trying to type up some answers to these, and so I'll make sure that these questions and responses are posted to our State Climate Office website after the webinar, so folks can look on there for links and resources. Let's see. So we have another question here. How much does shading contribute to the heat island effect? This is for Ken.
Yeah, well, the key for the urban heat island is, in terms of the overall effect, is how much stuff do you have on the surface that can actually evaporate water? And mainly that's, of course, vegetation. So the more of the urban center that can be covered with vegetation, or somehow, for instance, planting trees along sidewalks, it has an incremental effect on the magnitude of the heat island. Or maybe more importantly, for people who have to be outside, if you have areas of shade, that is certainly a major way to reduce the heat load on you, is to have some shade that you can kind of retreat to if you have to be outside. So that may be the more immediate effect that it can have, but also things like green roofs, for instance, can be used to change the amount of heat that normally the urban center would hold in concrete and asphalt and all that, and the green roof actually can evaporate, so it can mitigate some of the heat island effects.
And there's a really good example if you look at some of the work that's going on just to our north in Richmond, Virginia. The Science Museum of Virginia and several academic partners funded by NOAA have had an excellent mapping effort through the city limits in Richmond, and have actually gone through and seen the legacies of redlining in terms of which neighborhoods have tree cover and which don't, and then also now connected those to their emergency department visits. So they're taking that science and turning it into action by working through the sustainability committees and the planning departments in Richmond to begin to go back through some of those neighborhoods that have a lot of pavement that don't have adequate tree cover, and begin tree planting to try to mitigate that heat island impact in some of those neighborhoods. It's really exciting work.
That is really great to learn about. And it kind of relates to another question that we actually had come in on the pre-survey that I sent out, which is just thinking about, are there communities in North Carolina that are going to be impacted the most by climate change? And if so, you know, how do those impacts differ, and what are we doing to address that?
I think that, you know, generally we know that, you know, urban areas, low-income communities who are, you know, quite frequently also communities of color, indigenous communities, these are going to be some of the people who have the fewest resources to be able to adapt. You know, I am someone where I completely acknowledge the privilege that I have in that I was able to have enough funding to select a location and wait out and buy my own home in an area that's outside of a floodplain. Not everybody can do that. So I think that we have, when we think about climate change, we tend to stereotype, oh, it's the beachfront houses. But when you look at, you know, whether you're talking about people who are vulnerable to heat, people who are vulnerable to landslides and wildfires, people who are even vulnerable on the inner banks of North Carolina, where that land is very, very flat, primarily rural, low-income communities, these are going to be the people who suffer the most from climate change. So trying to come up with solutions, and I think come up with ways where we are working with these communities to find them solutions that they want, as opposed to we're going to step in and do solutions to them whether or not they like it, is a very important way to work. And it's the way that my office and my resilience team is committed to trying to do better and how we figure out how to address these problems.
Thank you. Yes, I think that comes to it's not going to be a simple thing to solve this, and we can't think about it in clear cut. There's a lot of nuance. Another question that had come in from a couple of people in the pre-survey webinar was about the pandemic and whether or not this has had any short-term effects on carbon emissions with potential long-term effects. I'm not sure if you're able to speak to this, either of you, and if there's anything you can share.
I think, you know, it's had some short-term effects. I haven't paid attention lately, but looked like there were some trends downward in emissions, at least relative trends. But from what I saw, the cumulative impacts is probably relatively small at this point. So if we were to get past this and the economy were to kind of re-engage at the full level, the net effect would be relatively small on the long-term trend in emissions.
Thank you. Another question that came in the chat is it on anyone's radar to increase the resiliency of farms by paying farmers to use cover crops and reduce tillage? The idea being that the mulch would help with adaptation and the increased sequestered CO2 would help mitigate climate change.
Yeah, I don't know about specific work from an agency perspective. I would probably defer that question to somebody over in agriculture. But what I will say is, you know, through our relationships through the State Disaster Recovery Task Force, we actually have an environmental preservation RSF and an agriculture RSF. And when they're not working on disaster recovery issues, blue sky conditions, we can turn our attention toward resilience. There are a number of groups, including the Environmental Defense Fund, who have done a lot of work on that in states like Iowa. about this time a year ago, I was able to take a field trip to Iowa with folks from North Carolina Farm Bureau, folks from Ag, folks from DEQ, Don Hardy, who's the mayor of Kinston, and Bill Sappho, who's the mayor of Wilmington, taking a look at their watershed approach and the ways that they have urban areas partnering with the small rural areas upstream in the watershed to try to look at not just the carbon benefits of no-till, but things like flood benefits and reduced farm runoff from having that kind of a no-till strategy, or mulching or cover crops, and the impact that that has on downstream flow. I would love to see more of that in North Carolina. I know EDS is really, really interested in these kinds of partnerships, and they've been doing a lot of work in Wayne County.
Great. I think we'll have time for just another one or two questions. Let's see. So one question that came in just now was, how will this all affect crop insurance and flooding insurance, if we have any guidance on that?
I do not know off the top of my head exactly a whole lot about how that works, but I can, we get my email out to folks. I can try to see if we can figure out who could answer that question. We've got some connections through our agriculture RSF that may be able to think about what's the realistic picture now, and what do we see responding? How do we see the industries responding in the future?
That would be great. Yes.
And in terms of flood insurance at this point, right now the flood maps are based on past conditions. So NFIP maps do not currently incorporate future conditions into flooding. So that's been something where it's still really a topic of research to figure out the best way to do that, because there is uncertainty, especially if you're talking about not just riverine flooding, but small creeks and flooding coming from stormwater runoff upstream. And how do you incorporate the uncertainty into what turns out to be a line on a map? So there's been a number of places who are working with FEMA as pilot communities to figure out how to do this, but we get that question a lot. The advice that I give people in the short term is to really, number one, have flood insurance, even if you think you don't need it. And number two, make sure that you're doing what you can to know what your flood zone is, and to know if you have an opportunity to do things either mitigating your home, your individual property, things like an elevation opportunity, and you need to do that to lower your flood insurance rates, you can. But local communities also have a role to play in this through the community rating system. And communities are able to participate in this program. It's run by FEMA, to accumulate a certain number of points, and accumulating a certain number of points and achieving a certain class manages to, each one of those classes correlates with a reduction on flood insurance rates for everyone in that jurisdiction. It can be a difficult program to manage, so continuing to work with communities but anytime you can lower that flood insurance rate through this kind of incentive-based program and things that are done at a community scale to reduce community scale risk, then you're making that flood insurance more affordable for the homeowner.
That's really great to know, yes, that there are things that can be done now, and that might be in your control at that community level. Well, I think that brings us to the end of our time. I do want to, again, just thank both of our speakers today I really appreciate the time and the expertise that you brought to this webinar. It was very valuable for me. I was very valuable for everyone who was able to attend. And I just want to say that this has been recorded, and I am going to post the recording once it's available at that URL at the top there, climate.ncsu.edu/climate-change_webinar. So hopefully pretty easy to remember. Everyone who has registered, I'll also be sending a follow-up email, and we'll include the link there as well, so you'll have it. And then I just wanted to, again, throw these dates up here for the upcoming webinars, and just encourage you to sign up if you're interested. If you've lost the link or can't remember if you signed up, just let me know and I can get you that information. So with that, I believe that we will end for the day and just say thank you.
Thank you.